So here we're going to do an example of an interval estimation question, similar to what we did before, but in this example there is a difference, which is that we know the sample standard deviation. And when we know the sample standard deviation, it's going to be a t-distribution question. And if you remember to the earlier videos, t-distribution has degrees of freedom. And with two sample t-distribution questions, the degrees of freedom had that horrendous formula. But there's going to actually, fortunately, be an Excel template which we can use here on exams to actually solve the degrees of freedom. So let's get on with this question. Specific Motors of Detroit has developed a new automobile known as the M car. 24 M cars and 28 J cars from Japan were road tested to compare miles per gallon. The sample statistics are below, so we see that. So when we look at that, M cars, there's 24 of them, as it says up here, and the average miles per gallon is 29.8, the sample standard deviation. So we have a sample standard deviation or population standard deviation, as I was saying earlier. That means we're going to use a t-distribution, and that is what determines whether or not we use t-distribution. The fact that we have sample standard deviation means t-distribution. And we're given the same sort of data for the second sample, which is J-car. So this is a two-sample question. We've got two sets of sample data. They ask us to develop a 90% confidence interval estimate of the difference between the miles per gallon performances of the two models of automobile. I like questions to be a little bit more specific than this, but this one's not overly specific. It's not telling us how to work out the difference. The difference is obviously the difference between the two. And since they've given us sample one first, we're going to take sample one as being our first sample, sample two as being our second sample. So let's have a look what they're actually asking us to find. They want us, well, let me put down the data first. Let me just restate the data. So we've got from the population of M cars, we've got a sample of n equals, so let's say n equals 24 cars. The average miles per gallon, call that x1, let's call that n1 as well, is going to be 29.8, given us that just there above. And the sample standard deviation, is called that S1, is 2.56. 2.56, that's not a very nice looking 5, but it'll do. And then we've got over here, we've got the J cars, and given the second sample, which is the sample here, sample 2. So sample 2 is made up of 28 cars, and the average, call it x2 bar, the average miles per gallon here for this is 27.3 miles per gallon, and the standard deviation, the sample standard deviation, is 1.81. There you go. So what they want us to do is find the interval estimate for the difference in the mileage between the two types of cars, American or Japanese. So if you remember, for confidence intervals, they all have this same basic formula. They start off with, it's going to be the point estimate plus or minus the margin of error. This is standard for everything. And the margin of error, just over here, the margin of error is just equal to the critical value time, and we're told the critical value, we know the critical value, this could be a t critical value, times the standard error. Now again, in the earlier videos, I actually told you what the margin of error would be. So it will benefit you if you actually have a cheat sheet which actually has all these results on it. So the point estimate is going to be x1 bar. For a two sample test, it's x1 bar minus x2 bar. There you go. And the plus or minus to get the upper and low limits. The critical value is going to be a t critical value. And for confidence intervals, it's always alpha over 2. The way we build them up, they have two sides. And the degrees of freedom are put up here. Well, we're going to have to calculate that using that Excel formula. That's the degrees of freedom. And we're going to have to multiply that by the standard error. And if you remember the standard error, right at the very first video for this section, it will be S1 squared over N1 plus S2 squared over N2. So most of these are straightforward. X1 bar is 2.56, X2 bar is 27.3, and S1 squared is 2.56 squared, and N1 is 24, like this. So this stuff's fairly easy to fill in. So let's focus a little bit more on these. I mean, I can put those in, but let's focus a little bit more on this value in here. Okay. So we've got T of alpha over 2 and the degrees of, a certain amount of degrees of freedom. Okay. So that's going to be, what was alpha for this question? Let's look back to see what that's going to be. Alpha, well, we want a 90% confidence interval, so alpha is going to be 10%. So alpha over 2 is going to be t of 5%. So this is what we need to work out, t of 5%. And a certain amount of degrees of freedom. Well, we're going to have to work out the degrees of freedom first, using that horrible formula, before we can actually do this. The formula for this is, in fact, well, so I put it in now, it's going to be t dot inverse. And then it's going to want the probability in here. What probability should I put in here? And then the degrees of freedom. What probability needs to go in there? What probability goes in? Well, let's just do a little diagram. If we've got a 90% confidence interval, it means that this area in the middle is 90%. It means that this area over, let's just do it over here, this area over here is 5%, yeah, that area in there. Oh, sorry. So the area in here is going to be 5%. And we're going to get another 5% here on the other side. But if we want to work out this critical value, we can work out either critical value. I like to work the one out on this side. The area to the left of that point is going to be what? The area to the left of that point, that's how Excel works, it's going to be 0.95. So basically we're talking about the area to the left of that point all the way down is going to be 0.95. They want the area all the way through. So if we find the degrees of freedom, we can go into Excel, put the degrees of freedom in here and come up with a solution for this part of the question. So what we're going to do now is we're going to go to titanium. If you look on titanium, if you scroll down, so it says template for unknown variances. Okay, so you're going to click on that, and when you click on that, this guy's going to open up in here. Let's have a look at that. Template for unknown variances. And let's just make that a little bit bigger so we can see more clearly what's going on. So we have to put in only the red data. We don't touch anything else. We don't touch anywhere else on this spreadsheet. So sample 1, we were told that the sample size was 24. And we have the mean mileage was 29.8. And what else? The standard deviation was 2.56. And now we do the same for sample 2. Sample 2, we were given, let's see, we were given that the sample size was 28. And we had the X bar was 27.3. And the sample standard deviation was 1.81. So we just go and put those through, and it gives us, it actually works out the numerator and the denominator, the top part and the bottom part of that horrible formula, and it gives us the degrees of freedom. It actually gives us the whole standard error. So if there's a question that asks you for a standard error, it actually worked it out for us. So the standard error, let's go back to see what the standard error is. It's actually worked out the standard error for us. So let's come out of this and go to here. So, by the way, the standard error was this thing in here, yeah? It's the standard error. So we actually found out that the degrees of freedom were in fact 40. So now we can go back and say, okay, this should be 40. So now I can work out the critical value, this part in here. So let's go over to Excel again. Let's go to a blank spreadsheet. And we're going to use equals t dot inverse 0.95 comma 40, and we're going to get a value of 1.68, 1.684, 1.68, and let's go back to our spreadsheet. So this value in here is equal to 1.68, so I can just put equals 1.68, 1.684, it's up to you, and then we just substitute into here. So it's going to be x1 bar, and we already know what x1 bar is, don't we? We know that x1 bar is just up here, x1 bar is 29.8, so now I'm just going to do the whole thing. So x1 bar is 29.8, minus x2 bar is 27.3, plus for the upper limit and minus for the lower limit, and we just worked out that value as being 1.684. And the standard error, we can work it out, but that's that thing that I told you about on the Excel spreadsheet when it gave you the standard error. We could actually work it out doing this calculation. So this will be 2.56 squared. Extend that out. So it's just filling in the numbers here. Moving down. So this is going to give us, this difference is going to be 2.5 plus or minus 1.684 times 0.625. Now 0.625 is just this thing in here, and if you check back to the Excel spreadsheet where we worked out the degrees of freedom, you'll see the standard error as being 0.625. So if we actually calculate that, it's going to give us a lower limit of 1.45 and an upper limit of 3.55. So what's that saying? That's saying that the average difference in mileage between American cars and Japanese cars is somewhere between 1.45 miles to 3.55 miles. So it looks like the American cars, based on this sample and 90% accuracy, looks like this sample saying that American cars do about 1.5 to 3.5 miles approximately more than the Japanese cars. And just to go quickly back, I said the standard error, this part here, the 6.25, we can quickly go back to the spreadsheet. Well, if you go back to the original spreadsheet, I think, oh, sorry, I deleted it. So if you remember, when you're doing that spreadsheet, you'll see that this was about 6.25. You can either calculate it here, or you can just pull it from the spreadsheet, and you can use the spreadsheet on the exam.